The incidence of speech impairments in children with cerebral palsy, stroke, traumatic brain injury, and the various neurodevelopmental disorders that we support at Home Bloorview ranges as high as 76%. Understanding the brain mechanisms that drive speech learning can inform our understanding of how to best care for children with speech impairments. One means of understanding how the brain controls speech is via auditory perturbation experiments. These experiments involve changing the audio responses someone receives in a speech task. For example, if a participant says bed, the word they may hear in a noise-canceling headphone could be the word bad, where the word they hear is altered just slightly from the word they say. The data from these experiments can be tedious and difficult to analyze, costing researchers time and effort. We identified a need for a fast, easy, and customizable software that analyzes audio data quickly and seamlessly. We started by scanning relevant publications to investigate how common data analysis techniques were conducted, which helped us identify the features the software would need to accommodate a wide range of studies. The software was developed in both MATLAB and R. MATLAB is a common programming language used in engineering and data analysis, and R is a common programming language used in statistical analysis. To supplement the software, a configuration file was created that allows researchers to change the settings of the software to fit their experiment. These results are an example of an output you might expect from a participant. There are participant graphs, which are essential for understanding their audio responses. There's also an information text file, which contains vital information about the participant and details about the analysis process. For example, the number of outliers that may have been removed. And it performs a mixed ANOVA, which is a common statistical analysis technique. This is an added feature for researchers whose setup falls under a facilitatory, control, and inhibitory paradigm. Also, for future researchers to understand how to use the software and its limitations, we created a manual that requires no prior knowledge of the software and no communication with us to use. This software is currently being used in an ongoing study with the Connect Lab in the preliminary stages. For researchers outside of Home Bloorview, the software will be shared through a commonly used code sharing application, GitLab. Overall, this software is meant to improve access and ease of use for running and analyzing outcomes of auditory perturbation experiments, which may result in wider uptake of this tool for understanding how the brain controls speech. This will ultimately inform treatment design and outcome measures in the future for children at Home Bloorview. Thank you, and please find me at poster number 8 for questions.